Okay everyone, this is going to be kind of an overview of the SKR 1.4 that I've installed on the Tevo Tornado. I'm going to show you here the screen in a close-up in a minute, but basically I've done a few mods to the printer in the past to make it a little bit stiffer and to make the printer itself a little bit quieter. One of which is these legs here. They have little 50mm rubber balls in the base so the vibration from the printer doesn't go into the tabletop that the printer is sitting on. I've installed frame braces in the back. You can't really see them from this angle, but we'll change the camera angle in a minute. There's two frame braces to keep this from moving around when the printer is wobbling. And I've also changed the extruder up here. I know the extruder it comes with, the extruder assembly I should say, it's supposed to be a good extruder, but I had slippage problems on Protopasta's carbon fiber, so I just printed my own extruder, put a Mark 8 direct drive gear on the motor and swapped it out, so no more drive issues. But that's pretty much it, except for the adjustable Z height over here, so you can change where the Z height zeroes out. But not too many major upgrades to the frame other than the extruder and the braces. Obviously I put these little guide wheels on here for the filament and whatnot, but the main thing I wanted to go over in this video was the SKR 1.4 board, which Big Tree Tech makes. They're a company in China that makes 3D printer boards that are really cheap compared to their competitors. It's a 32-bit board instead of an 8-bit, so a little more power. This is the turbo board, not the standard. The only difference is the processor was a little bit quicker and the memory's a little quicker on the turbo board. So since technology goes outdated so quickly, I decided to use the turbo instead of the standard board. And it did fit into the box pretty well. I wasn't able to use all 4 mounting screws, so I was only able to use 2 without modifying the actual box or printing an adapter. But it doesn't really matter as long as the board is held in place and it can't, move around or short out, then you're good to go. So it was almost a drop-in installation. I did have some issues with the installation of Marlin 2.0, getting it to work with the TMC drivers, but I'm going to show you the screen in a close-up here so we can go over that really quick. So this is what the screen looks like in Marlin 2.0, which Marlin 2.0 is a little different than the original Marlins, the 1.0 versions. And on this particular version, it only works on 32-bit boards. So this is how it's going to look when you start it up. I've named the printer a Silent Tornado, which you can see scrolling across the bottom there because it's so quiet. And it just says Silent Tornado SKR 1.4. As you can see in Marlin 2.0, it has these little question marks flashing on the XY axes. And that just means that the printer hasn't been homed yet, so it doesn't know where the motors are. But it works kind of similar to the old Marlin. The issues I had with the TMC drivers, I ordered the board with the drivers because the drivers from each manufacturer are customized. So the SKR TMC drivers, I think they're 2209 drivers. The 2209 drivers are customized for the Big Tree Tech board, so I just went ahead and ordered them as a combo. The only issue I had was getting the drivers to enable because when you go into the configuration .advanced.h in Marlin 2.0, there's an option called software enable. You need to make sure that that's commented out. You don't want to enable that line, so make sure that line is commented out. That was the problem I had. I couldn't get the actual motors to move or do anything. They wouldn't home, they wouldn't move, they wouldn't make any sound. So I did some hardware lead testing on the drivers themselves and determined that the hardware drivers were actually powered on and working, but there was no current on the outside, on the output side of the drivers. So the driver was on and working, but there was no output current going to the stepper motors. So after I finally figured that out, it took me about a week and a half to figure out that the drivers were working, but there was no current going to the motors. Then I was able to go back into the Marlin file and try and figure out what I had set wrong. And I eventually did find that one line in the code, disabled it. And you would think that a software enable, I'm going to show you really quick here. When you go under configuration, you can go down here to advanced settings, and if you keep scrolling down, it goes down and it shows you TMC drivers right here. And from here you can set the current, which I have set at 700.7 amps or 700 milliamps. And then you can turn on and off the sensorless homing. Actually, sorry, you can't turn it on and off, but you can set the sensitivity. So I have the sensitivity set at 130, which is about right for the Tornado. And then you can go in here to the stepping mode and you can turn on the stealth chop. I have it on for all axes, so they're all running in silent mode, including the extruder. But normally in the old Marlin, let me show you here in the main menu. In the older Marlin, you could go into here. I don't remember if it was right here in the first menu or if it was under motion, but you could scroll down. Yeah, here it is. There was an option in here that said enable steppers. And in the Marlin 2.0, there is no enable steppers unless you're running a G-code file. So the only way you can enable the steppers is to send the command either over USB from a PC, or you have to have a G-code already running, and then you can disable the steppers. And when you go into this menu here under motion, you'll see the option to either disable or enable. But on the Marlin 2.0, there is no enable option. So I was having trouble enabling. I kept looking in here for the enable option for the stepper motors, and it wasn't here. And I thought that's why the drivers were not putting out current to the steppers, because if you disable the stepper motors, then there's no current going to them. But as it turns out, it was just a difference in the old Marlin 2, or the old Marlin 1.0 and the new one, the 2.0. So I did end up doing the driver enable through a G-code command from a PC, and it did enable the drivers, it did enable the steppers, but then I believe, I can't remember the exact command, I think it was the M122 sends you the driver status of the TMC drivers. Even though you had enabled the steppers with the G-code, it would show that the drivers were disabled. So it would show that the drivers were powered on and working, but their status was disabled. I think there was a false flag showing they were enabled or disabled. So you would think intuitively that the software enable would be the option within Marlin, right, to disable or enable the stepper motors. But in fact, that is some kind of other option. I don't know exactly what that option is for, but you don't want to have a software enable because there is no way to enable the stepper motors as far as the output current from the drivers. So just make sure you don't enable that. Make sure it's commented out in the Marlin 2.0 and you should be good to go. I'm going to include the Marlin sketch files, so all you should have to do if you have the Tevo Tornado is put them on your SD card and you'll be good to go. It just replaces, I think it's just called a firmware.bin file. So if you just copy your new file that you've compiled over onto your SD card, replace the old one, don't change the name, and then when you pop it back in, it should flash and update. The only issue I've noticed with Marlin 2.0 is that sometimes it gets stuck in a boot loop, and I think that has something to do with the SD card. And this SD card just has G-code print files on it. There is no firmware on here. But for some reason, I don't know if it might be a certain character in the file name, like an underscore, or possibly just the amount of files, like 20, 30, 40 G-code files. Something is messing up the boot of Marlin 2.0, so if I reach around here and turn it off, and then I'm going to insert the SD card. And normally you would just leave the SD card in the printer. Obviously there'd be no point in removing it. But let's see if it'll do it. It doesn't always do it, but sometimes it just continuously loops through the boot. Yeah, see, it's gonna boot loop here again, and it'll keep doing this screen, this boot screen, over and over, and it'll never completely boot up and show you the Marlin screen. And all you have to do is pull out the SD card and it will boot. So I'm just going to pull out the SD card now so that it will finish booting, and you can see almost immediately it went ahead and booted. But if I hadn't pulled the card out, it would just keep looping. And it doesn't always happen. It's kind of weird. I don't know. Like I said, it could be a character in the file name that's messing it up, one of the G-code files, but I haven't figured out exactly what the problem is. So if you have a boot that's looping, just make sure you don't have any SD card plugged in with G-code files on it, and it should go ahead and boot up. And then you can just plug the card in, and you can see at the bottom there to go from media removed to media inserted or present. There you go. And now I can go select my G-code files. So just a quick note on that one if you get stuck in a Marlin boot loop. And the only other thing I wanted to note about installing and compiling the new Marlin 2.0 for this board, because it's a 32-bit board, is you can't compile a 32-bit version of Marlin, which is 2.0 and above, with the Arduino IDE, which is what most people were using to compile Arduino, or to compile Marlin. Most people would use the Arduino IDE. And once you move to a 32-bit version of Marlin, you can't use it anymore. So you have to download Visual Studio Code. It's just called VS Code usually. So I wasn't familiar with that program, but I was able to download it and figure out with a few videos how to navigate and at least get my files loaded in so I could compile the version of Marlin that I needed. But yeah, don't try and compile Marlin 2.0 with the old Arduino IDE because it won't work, and you'll either get a compile error or you'll go to flash it and you'll ruin your board because the flash will fail. So make sure you install Visual Studio Code or VS Code, and that will allow you to compile it. I'm going to put 2 links in the description. There's 2 other videos out there where these gentlemen have done reviews on the board itself, detailed reviews on the drivers and everything. And they show how to compile Marlin, how to go in and set all your options, and how to install and use VS Code. So I'm going to just put links for those because I'm not going to go over them in this video. But okay, so this is just going to show you guys really quick how the circuit board was hooked up in the Tevo Tornado. Right here in the fan 0 port, this is the part cooling fan. There's only one fan plug that you can use that has a variable speed. All the other fan plugs are just going to be on or off. So on fan 0, this is the one you can control. The wiring is backwards, so you're going to have to release these little connectors and switch them. Normally the negative here would be on the left. But that's going to be the part cooling fan. This is all from memory, so some of this could be a little wrong, but as far as I can remember, this is the DC input here on top, 12 to 24 volts DC, and then right below it you have the extruder hot end 0. It only has one extruder hot end if I remember right. And note that these the polarity on these plugs is different. The DC inputs are backwards compared to the heaters, so triple check these when you connect them so you don't connect them backwards and short out something. And then these next 2 sets of sockets here are going to be your bed heater 1 and your bed heater 0. So bed heater 0 is going to be the heat bed and the fans inside the box here, which are already, you can see that's why they have these wires joined together into the little solder clamps, is because when the heat bed heats up, the fans in the box ramp up to cool down the MOSFETs and stuff as they draw more power. So this is going to be the actual bed, and then the bed heater 1, which normally you wouldn't use, this is going to be the extruder fan. So this is just going to be a simple on-off, which is going to run the extruder fan at 100% all the time so that the hot end doesn't overheat as it goes up through the heat break toward the PTFE tubing. And then up here in the top left corner of the board is the thermistor connectors for the hot end and the heat bed. And then right here, the only end stop we have connected is the Z or Z end stop. The X and Y, we use the sensorless homing, so we don't need the end stops connected. This is just showing the motor drivers. I believe this is X. You can see I'm marked here. This is X, Y, Z. And this is the extruder. And then on the plugs over here you have X, Y, Z. And then you have a double Z here in case you had two Z motors. So we didn't use that because we only have one. And then this is the extruder plug here. And then this is a further shot picture, further back picture. This is the solid state relay that controls the heated bed because the bed is actually heated with AC power. So earlier when we looked up here at the heater bed 0, all this does is basically toggle this relay on and off so that the AC power can flow to the heat bed and heat it up. And obviously make sure that this is disconnected from your AC power because this has 120 volts AC coming up to the relay, so make sure everything is unplugged from the wall power before you open up this control box. And then the last picture here would just be kind of a top-down view with the LCD screen connectors. I wanted to show that they're backwards, so this top one actually ends up right here on EXP1, and the bottom connector swaps up to EXP2. This is your USB port, and this is the SD for doing the firmware flashing. I did the firmware flashing before I mounted the board. You can see there's nowhere for it to go. It's underneath this fan. And you can also see the USB doesn't line up with the hole in the box anymore because it's in a different spot. And I could have dremelled it out, but I never run this printer over USB, and I had all of the settings correct when I flashed the firmware, so I had no need for this really. I just left it the way it was. So that's pretty much it. I'm going to go ahead and show you guys now a video of how the printer sounds when it's running. And obviously it's not silent because you're going to have the fans, the little part cooling fans and the nozzle cooling fans, but it is silent other than the fans. So okay, so here it is printing. I know the fan is going to be mostly what you hear. I've got a pretty sensitive mic aimed at the printer so you can hear what's going on, but I'm going to stop the fan for a minute here. I don't have any plug out here on the outside where I can unplug the this is the cooling fan for the heater block. If you turn that off for too long, you might end up with a nozzle clog because the filament needs to be cooled right there in the choke point. So I'm just going to use my finger to stop the fan for a minute here so you can hear just how silent the motors actually are. And you might be saying, well, the printer's running kind of slow anyway, but that's only because it's printing the first layer here and it's making sure that it adheres well to the bed. Once it speeds up, it's going to sound pretty much the same. I'll show you a short clip of that later, but I'm going to stop the fan really quick here so you can hear it. And you can see there in that little pause, you can hear the fan down here in the control box running because it runs at a variable speed depending on the power draw you're pulling. But the steppers themselves, you can't hear them at all. The TMC 2209s are so quiet, and these are just stock stepper motors with the Tevo Tornado. The motors have not changed. You could buy a replacement stock motor and it will sound exactly the same. They're literally so quiet. If you get I'd say within 1 foot of the frame here, you can barely hear the motor sound with your ears if you listen carefully, but that's in a silent room with no other sounds and no fans, nothing else. You can barely hear the resonation of the motors in the aluminum frame, but when you're standing a couple feet away and the cooling fans are running, you literally can't even hear the motors. There is no motor sound. If you exceed maybe if you exceed 60 millimeters a second print speed, you might start hearing them a little bit. If you've got travel moves that are above 100 millimeters a second, you can hear the motors when it travels, but that's it. As soon as it goes back to printing, the sound of the motor disappears. So you can literally print this thing and be working right next to it. You could probably even sleep while it's printing and you wouldn't even really hear the printer running. All you would hear is this little fan running. So they're pretty quiet. I would say if you're trying to get a good value printer modification, then this would be the one to use. Not only do you get a 32-bit board to support future software that requires it, because we all know everything gets faster and faster every year, every 6 months, so it's good to have a faster 32-bit processor for future software platforms that are going to come out. But even if you just want the printer to be quiet and you don't care about the software side of it, there is nothing that's going to make the printer quieter than this. You could buy an enclosure and enclose the whole printer, but even with an enclosure, if you were running a stock board, you would still hear the motors through the enclosure. So if you want a silent printer that won't annoy you while it's running in your office or working space or wherever it is, if you're in that area while it's running and the little whine of the motors is driving you crazy, then I would highly recommend buying the SKR 1.4 boards with the 2209 drivers. You don't have to buy the turbo, and they have other versions of the board that support the same 2209 drivers, but some of their older boards don't support the 2209s. They'll support some of the older TMC drivers. I chose to go with the 2209s because they handle the highest current and they run the coolest. Some of the other TMC drivers are equivalent as far as the decibels that they produce in the driver motors, the stepper motors, but they run hotter at the same current levels. So I said, why would I want a hot running driver that's going to potentially burn out eventually because it's down here in a control box, a control box with a fan. So better to have cooler running electronics. The cooler they run, the more efficient they are electrically. So very happy with the SKR 1.4 and the 2209s. I'll let you hear this one more time. You can see the movement of the printer is just silent. There's no sound coming from the stepper motors, so really, really, really quiet. And this is just a quick shot of that extruder I mentioned earlier. It's actually the extruder assembly, I guess you would say, but not technically the extruder. But this is a shot of the extruder I mentioned earlier. It's just 3D printed. I'll include the files in the links, and you can see it doing all the retractions there. It's just a Mark 8 drive gear. I tried to use a Mark 7 drive gear, and the Mark 7 is too large for a regular 17-ounce NEMA motor, so you end up with the motor skipping steps, which means that your extrusions are also missing consistency, which causes major print problems. You can't print like that, so I ended up dropping down to the Mark 8 gear, which is smaller, it gives you more torque, and I have had zero problems as long as you have the temperature of the extruder correct for the type of filament and the print speed you're running at. There's no issues with this one, so no slipping. I can run the protoplastic carbon fiber through. It doesn't mess up the teeth on the drive gears, so I'm pretty happy with this extruder assembly and drive gears, so no problems with that one. It's kind of behind the wiring right here at the moment, but you can see in the background there, that is the frame brace I was talking about. They're just 3D printed braces that bolt onto the V-slot channel, and it just goes up out of the frame here and connects to the top with another printed bracket. So nothing super fancy, but it's kind of important, especially when you're printing faster, to keep the printer stable so your nozzle isn't moving around where it shouldn't be. Obviously you have to buy some more V-slots, so this can be bought at Open Build's parts store. You will have to buy, I think I used roughly, I want to say like 600 millimeters per stick on the back. I don't know the exact dimensions, I'll include them, but you're going to need some more to put the braces on there if you want to put the braces. And this is just another quick shot of the printer while it's printing, so you get an idea of the sound with a different mic. This is the camera mic. So I am going to include a short clip of the printer before I installed the board so you can see just how noisy they actually are. You don't realize how noisy the standard 8-bit printers are until you hear a TMC driver next to it and you're like, whoa. Sound like a rocket next to hummingbird. And I'm just printing some of these. These are the little mask extenders that you see people wearing now that everyone's wearing masks thanks to the coronavirus. So I'm just printing some extras up for people that wanted them. And just really quick, the one last thing I forgot to mention about Marlin 2.0 is that you can change the stepper motor current in the menus that I showed you earlier, and that will override the values that you've included in your firmware.bin file. So if you use the bin file that I've uploaded and you just throw it straight onto the printer, and you're using, let's say, maybe an Ender or another one of the Creality printers that are similar, and you want to change the motor current a little bit, all you have to do is, after you've flashed it, you can go into that menu through the Marlin screen here on the front of the printer, and you can change the current, the motor current. So if you change that and save it to the EEPROM, it will override the values that are included in the firmware file. So you don't have to hard code the correct values into the file. You can go in and adjust them, save them, and you're good to go. You don't have to reflash the firmware every time. So, and if for some reason you want to turn off the silent stepper mode, you can turn it off in the stepper motor menu that I showed you earlier as well. So pretty easy to change. Just make sure you save your settings to the EEPROM, or when you turn the printer off and start it back up, you may lose your adjustments. And one quick note also, as far as the quietness of a 3D printer, is if you want a really quiet 3D printer and you're looking to buy one, you want to get one with these V-slot extrusions and the little wheels. These little Delrin wheels are extremely quiet, and they use a standard ball bearing, what they call a radial bearing. These types of bearings and wheels are really quiet compared to a linear bearing, for example, that slides along a steel rod. So if you're looking at a printer that has stainless steel rods or carbon rods or whatever, if it uses linear bearings, it's going to be noisy. So if you put your 2209 drivers and your 32-bit board on your printer, you're still going to hear those linear rods as they go back and forth. Especially probably the x-axis will make the most noise, because usually you have the most travel motion on this axis. The y doesn't move too much depending on the print you're doing, but whatever axis is moving the most, the x or the y, you're going to get noise from linear bearings. So even though your stepper motors are going to be silent, you're going to get physical noise from your linear bearings. So I would recommend, if you don't have a printer yet, buy one with the V-slot rails. It's going to be quieter afterwards when you change out the stepper motor drivers. If you already have one with linear rails, if you already have one with the stainless steel rods and linear bearings, you can buy nylon bushings, and you replace the linear bearings with the nylon bushings, put a little bit of grease on them, and they slide along the steel rods, but they're much quieter. So that's just a quick note. A lot of people don't know that the linear bearings are very noisy compared to these V-slot rails. So ideally you want a printer with V-slot rails if you're going to go for a quiet print.